you will learn about the basic structure in a foundation, the loads on them, and the process of foundation design and software used for it. The basic structure of a foundation is a load-bearing wall, or a column, resting on a slab called footing, which finally rests on the soil. In deep foundations, the column rests on a pile cap, which in turn rests on the piles running deep through the soil. In all of these cases, the load travels downwards, through the elements, into the soil. While these compressive loads may travel through the axes in case of columns, they act as line loads in walls. The objective of a structural engineer, in the design of foundations, is to ensure that the structural loads are transmitted to the subsoil, safely and economically. It should also happen without any unacceptable movement, during the construction period, and throughout the anticipated life of the building, or structure. Stability-wise, the load that is transferred to the soil should be less than the soil strength. This will prevent from any failure in shearing of soil. Also, considering the serviceability parameter, the settlement of the building must be less than the allowable values of settlement. Let's take a look at the basic procedure for design of foundations. The first step would be to assess the conditions of the construction site. Here, the geotechnical engineer will generate the soil investigation report, from where you can find the soil strength and bearing capacity. In the next step, you need to calculate the anticipated loads on the footing. These loads are found out by analysis of the superstructure. They differ based on the types of loads and their points of application on a building structure. After getting these values, you will choose the most accurate foundation type for the given conditions. As explained in the previous videos, the criteria for selection of foundation type depends on various factors, like soil conditions, incoming loads, type of superstructure, economic and time factors, and local construction problems. After completing these steps, you will proceed with the design of the footing. The design footing should be safe against failure. Here, you will determine the area and thickness of the footing, the concrete and reinforcement materials to be used, and generate their detailing diagrams. Let us now take a look at some of the effects of improper or incorrect design on the foundation and the structure. The foundation of a building might develop cracks if the design depth is not sufficient. This is due to the movement of the foundation when there is a change in the water table. When the width of the foundation is not adequately designed, it results in the settlement of the foundation. This will, in turn, result in cracking of the walls of the superstructure. This cracking of walls might also occur due to presence of soft spots in the subsoil, which renders the soil insufficient to support the structure. The walls are displaced laterally due to the presence of vegetation in the soil, resulting in sliding or creeping. May expand and deteriorate, as the high amount of sulfate and clayey soils may attack the concrete. In foundations near drains, if the support is not adequate, it will also result in the lateral movement of walls. In some cases, the cracking of the structural elements is so severe that it leads to collapse of the building itself. This happens when the support to the foundation from landfill is inadequate. Consequently, this leads to excessive settlement of the structure. In this course, you are going to learn the foundation design of shallow footings with the aid of a software. In today's age, the use of software over manual procedures has rendered the design and analysis process into a much more efficient task for structural engineers. Engineers now have greater flexibility to run different cases of analysis and on different kinds of building models. Calculations in software result in fewer flaws as compared to human error. Thus, it results in saving of a lot of time, and hence, you can generate more and better designs in the same time. There are quite many software available for the purpose of structural design of foundations. The software that you are going to use in this course is SAFE. The reason SAFE is preferred is because it requires less disk space in your computer system compared to others. They have a better design processor which helps in running structural design efficiently. They also have comprehensive provisions for the design codes, integrated in the software. It is for these reasons that SAFE is used by top design firms in the construction industry. Most importantly, SAFE has a free-to-use evaluation version, which is beneficial for students to learn it without having to pay for licensing. In the next video, you will learn about the mechanics of soil. Thanks for watching.